Welcome back to this session. Here, oh, my screen it's not shared. It's not shared. I believe that I was sharing it. Entire screen. I think I should share the entire screen. So we had finished. We had completed the what? The Fehling reagent, and I said that for that reagent, it is a redox reaction, by the way. Aldehydes for that reagent, toluene reagents, aldehydes reduce toluene to elemental, reduce toluene to elemental silver, and they are oxidized. They are oxidized to ketones. Then reagent 4 is the Fehling solution. Fehling solution, this is a mixture of what? Copper 2 sulfate solution. It's a mixture of copper 2 sulfate solution, sodium tartrate, and excess sodium hydroxide solution, and excess sodium hydroxide solution. Yeah. Fehling solution is the same as copper 2 sulfate solution. Sodium tartrate. Sodium tartrate is sodium oxide complexed with the carbon and hydrogen. Yeah. However, this sounds too much of it. It's more of a technical term. Yeah. Kindly stick to Fehling solution. That is enough. But the Fehling solution here is made up of copper 2 sulfate solution, sodium tartrate, and excess sodium hydroxide. However, without this sodium tartrate, we have copper 2 sulfate in sodium hydroxide. In some books, you'll find out that they call it Benedict solution. However, in chemistry, never use Benedict solution. I am including this for those of you who read a lot of books. Yeah. For me, who doesn't read a lot of books, I use Fehling solution. So Fehling solution is what you should stick. It's what you should stick to when you check the chemistry books. Those which you are using at this level, you find them using Fehling solution. You only find that for chemistry purposes. But if you want to know it technically, it is copper 2 sulfate solution with sodium tartrate. Sodium tartrate, that is sodium oxide complex with carbon and hydrogen, and excess sodium hydroxide solution. In some books, you also find it being called Benedict solution. So I want to say that aldehydes, in this case, aldehydes, they give a positive test. In some books, they'll call it ready precipitate. Others call it reddish brown precipitate. Also brick red. Am I on? I think I'm on. Brick red precipitate. Ketones do not give positive test. Do not give no observable change. So how does this thing look like? Allow me share my screen. Hope it is visible. Yeah, it is. It's visible. Now, when you check on the net Fehling solution, let me use this C8 here. This one here. Hope you are seeing it. Did I use? Okay, let me use this. I don't know. Okay, maybe this. Or this. Now, are you seeing these images? The one in blue, corresponds to a negative test. I've told you that Fehling's is made by dissolving copper 2 sulfate solution in excess sodium hydroxide. So copper 2 sulfate solution in excess sodium hydroxide, that is a blue solution. When you add a ketone to that solution, the solution remains blue. So we do not observe a different color, remains blue. So nothing much is observed. However, it becomes red once an aldehyde is there. If you observe an aldehyde, as in if you are dealing with an aldehyde, you see a red precipitate, or in some books they call it brick red. Yeah. So the positive test for aldehydes is reddish brown precipitate, brick red. Yeah. And that brick red precipitate is for, have I noted it? It is for copper 1 oxide. Red precipitate, reddish brown precipitate, or brick red precipitate of copper 1 oxide. So what is the equation? In some books, you'll find out that, by the way, also here, benzaldehyde. Benzaldehyde is a bit stubborn. Yeah, it's a bit stubborn. Most of the literature reports that benzaldehyde does not undergo this reaction. Most of them. However, there are those that note that it undergoes on heating. So it is a bit chaotic. I don't want to comment on it. Yeah. Because most of the practicals, I think, anyway, it can be. I'll comment on it later on. So these are copper ions with the sodium hydroxide. Wow. Copper, the aldehyde is going to reduce copper 2 ions. Yeah. I've told you Fehling solution is made by dissolving copper 2 sulfate in sodium hydroxide solution. So it reduces it to copper 1 oxide. Then the Fehling's oxidizes it to a carboxylic acid. Like that. So meaning that if I am having ethanol is going to be oxidized to what? It reduces copper 2 to copper 1 oxide. This is the brick red precipitate. The red PPT is this one. Then itself is oxidized to sodium ethanoate, like that. Ketones do not react. Ketones do not undergo that type of reaction. Benzaldehyde. Benzaldehyde is a bit stubborn. Benzaldehyde. Most literatures you find them quoting that benzaldehyde shows no reaction. Shows no reaction with the Benedict solution. Benedict solution under ordinary conditions. Also note that in some books, the equation above also, the equation above can be written in this form. For example, taking an example of, okay, let me write the general one. RCHO with copper 2 sulfate, sodium hydroxide. What do you get? Copper 1 oxide, the brick red precipitate. The other thing is oxidized to RCOO like that. So what do we have? What do we have? I think there is water. I don't know. I think there is water. Anyway, let me first balance and see. If I recall very well, there is a 2 somewhere. I hate balancing equations. So how can I balance this equation? How can I balance this equation? How can I balance it? Now I'm seeing it is going to create problems. It is going to create problems if I have used ionic. Now, if I have used ionic, I think let me also maintain, because yeah, this Na should not be there. Oh, I was making a mistake here. Sorry. So if I don't use any, like here, if I don't apply sodium hydroxide, this will be in ionic. This will be ions. Also, this will be ions. Yeah, sorry for that. What I'm saying is that if I use the, let me note it here. If I use the CH3, CH2, CHO with the copper 2 sulfate solution, sodium hydroxide, warm, I'll get Cu solid plus C, that is propanol, sodium propanoate, like that. So I quote the sodium, I include the sodium if I have used sodium hydroxide, but if I use hydroxide ions, I do not quote the sodium. I have, for that case, I write an ionic equation. So that will be formed as if propanoate ions. So generally, I was also noting that if it is CH3, CH2, no, let me use the general one. R, CHO, liquid, plus copper 2 ions, plus sodium hydroxide. Now I have used the hydroxide ions, meaning that this side I'll get the brick red precipitate plus what? R, these are now ions. Don't include the sodium if we've used the hydroxide ions. I think there is also water. Yeah, there is water some. Anyway, let me pass. If I put a 5 here, if I put a 5 there, those are what? Those are 6 oxygens on the left. 6 oxygens on the left. I think I'm going to need, this side I'm having 3, so I'm going to need 3 moles of water. If I put 3 moles of water, look at the hydrogens on the left. There are 6 hydrogens. Also on the right, there are 6. Copper, I think I needed 2 here. There are 2 coppers. Also on the right, there are 2. I think now it balances. Yeah, it balances. So generally, that's how we can we can use Fehling solution. As of now, allow me first to stop here.